All right, now let's get into another topic called the conversion of alcohols. We do have a lot of different styles being alkyl halides and tosylates, which I'll be doing some problem solving skills with those. Alkenes is a little bit of a review of chapter 8 and a chapter 11 combined. Creation of esters is new for this chapter, and we have already completed carboxylic acids and aldehydes. We created these two by using oxidation and reduction techniques. So let's go and start with alkyl halides. The conversion of alcohols to alkyl halides. Now, this is just a general summary, but guys, we will be getting into mechanisms shortly. Now, when I start doing mechanisms, I tend to do them on separate videos per topic, just in case your instructor emphasized one more than the other, so you can kind of pick and choose at that point which ones you really need help on. So that's just how I'm going to do that for now. So when it comes to your primary and secondary alcohols, there's two different reagents we can use. We could use SOCl2 and pyridine, or PBr3 and pyridine or ether. You'll see that I tend to normally avoid giving you the actual name of structures because y'all really don't care. So why bother you with those things? So the big things that you need to know is how to apply. Whether you have a primary alcohol and you decide to use either one of these, the simplest thing is converting the alcohol to whatever halide you have in that presence. So if I use SOCl2, change it to Cl. If it were a Br, then it would look like this. Simple enough. Same thing with the secondary alcohol. If you use the SOCl2 or if you use the PBr3, these are the structures you would get. Now, recap. What did I say to do at the bottom? Stop, review SN1 and SN2, and you will need the mechanisms. So for primary and secondary alcohols, they will go through an SN2 reaction, which you have to review, but in some summary, I guess, this one goes through a concerted mechanism, and it causes inversion of stereochemistry, which means if I start off with something that is wedged, in my final answer, it will end up as dash. Now, again, depending on which reagent you use, you would just be substituting the Cl or the Br. Now, in problems that are like this, they tend to ask you to assign R and S notation because that's a clear chirality center. So here's another instance where you must review and see that this particular molecule starts off as an R notation. So I should expect this to look like R, but really both of these would be S, and that's the definition of inversion. So review SN2. Tertiary alcohols can go through a multiple of things. They tend to go through SN1 and E1, but right now we're going to keep everything separate in just the substitution land being why it begins with an S. When we start talking about E1 and E2 is when we're talking about elimination reactions, which will yield us double bonds. In this case, we're substituting what we had and replacing it with something else. So now this is HX over 0 degrees Celsius is normally your hint, because later on this can change to something else and it will change the style of reaction. So in this case, same idea. We're replacing the OH for whatever halogen they use. You don't see fluorine used very much, only because it's very reactive, but either way, again, it's just a direct replacement. So now we're going to go into working all three styles of this mechanism separately. So please prepare to open up your minds when it comes to understanding mechanisms and how the arrow movements will go.